Total darkness. The only sound, water dripping somewhere in the void. Then, the flutter of wings, thousands of them echoing off stone walls that haven't seen sunlight in millennia. We're inside a cave system on the Caribbean island of Marie-Galante, roughly 20,000 years ago. And something is waiting. A bat veers left, its echolocation painting the cave in sound. It doesn't see the coil draped along the limestone ledge, doesn't register the heat signature locked onto its flight path. The strike comes in 0.1 seconds. No rattle, no warning hiss, just physics and hunger. The bat never makes it to the cave entrance, because on this island, death didn't crawl on the ground, it waited in the dark, and it had no legs. Island Prison. Marie-Galante today is paradise. White sand beaches, sugarcane fields, crystal water so clear you can see 30 feet down. But 20,000 years ago, this place was a biological prison. See, when sea levels rose at the end of the last ice age, Marie-Galante became isolated from the rest of the Caribbean archipelago, and isolation does strange things to evolution. Scientists call it island syndrome, when species trapped on islands begin adapting to extremely specific niches because there's nowhere else to go. No competition means no rules. On Marie-Galante, there were no big cats, no wolves, no apex mammalian predators at all, just birds, lizards, bats, and one evolutionary experiment that would dominate the caves for thousands of years. Its name was Boa blanchardensis. And before you picture some 20-foot anaconda, let me stop you. This snake maxed out at about 1.39 meters, roughly 4.5 feet. In the snake world, that's modest. But here's what matters. It didn't need to be huge. It needed to be perfect. And in those caves, for that prey, it absolutely was. Anatomy of an assassin. Let's talk about what makes a ground-dwelling constrictor decide to hunt flying mammals in complete darkness. The fossils were discovered by herpetologists Renal Bocaton and Sandrine Bayonne in a Marie-Galante cave system alongside thousands of bat bones. And here's the thing, the snake bones were inside the cave too, not near the entrance, not in a burrow nearby, deep inside. This wasn't a snake that wandered in and got lost. This was a snake that lived there. The skeletal structure shows adaptations we see in modern cave boas, like the Puerto Rican boa, which also hunts bats. Slightly more robust vertebrae for anchoring to irregular rock surfaces, a jaw structure optimized for prey that doesn't fight back much once it's caught, because bats, for all their aerial agility, are fragile once grounded. But the real evolutionary masterpiece? The sensory system. Bats use echolocation, biological sonar. They're basically flying with their ears, painting the world in sound waves. And Boa blanchardensis couldn't hear that, but it didn't need to, because it had something better: thermoreception. Boas have heat-sensing pits along their jaws that can detect temperature differences of less than 0.003 degrees Celsius. In a cave where the ambient temperature is constant and cold, a bat's 40-degree body temperature might as well be a searchlight. The bat thinks it's invisible. The snake sees a heat signature moving at 25 kilometers per hour in three-dimensional space. It's not a fair fight. The hunt. Picture the scene. You're a nectar bat. You've just spent the evening gorging on hibiscus flowers outside the cave. You're fat, happy, and ready to roost. You enter the cave mouth, wings folding as you prepare to latch onto your usual ledge. The snake has been motionless for 6 hours. It doesn't breathe heavily, doesn't fidget. Reptilian patience is something mammals will never fully understand. And in the pitch black, draped along a limestone overhang, it's just another contour of rock. Until it isn't. The strike happens faster than a human eye can process. The bat is seized mid-flight, not in the neck, but center mass. The snake's recurved teeth punch through fur and skin, locking in like fishhooks. The bat shrieks, but there's no escape. The coils are already wrapping. Constriction doesn't crush, it suffocates. Every time the bat exhales, the coils tighten. Inhale becomes impossible. Blood pressure spikes, brain goes dark. 45 seconds later, the bat is dead. Now comes the hard part. The snake is dangling from a cave ledge anchored by its tail with a dead bat locked in its coils. Gravity is not helping, and swallowing a bat, wings, fur, echolocation apparatus and all, takes time, sometimes over an hour. But Boa blanchardensis had time. It had endless, patient Pleistocene time. And then, the world changed. Not dramatically, not in fire or flood, just slowly, the way everything actually ends. The Pleistocene gave way to the Holocene. Sea levels rose, the climate warmed, the vegetation shifted, and the bats, the island's primary source of aerial biomass, began to decline. Maybe the caves flooded, maybe the flowering plants they fed on changed, maybe human arrival on the island 3,000 years ago disrupted the ecosystem in ways we still don't fully understand. But the fossil record is clear. Boa blanchardensis disappears from the geological timeline without a struggle. No evidence of disease, no signs of human predation, no catastrophic event. It simply wasn't needed anymore. The caves went quiet. The perfect predator had evolved for a world that no longer existed, and when that world vanished, so did the snake. Not with a fight, not with a last stand, just a slow fade into the fossil record. So, here's what we're left with. A snake that never made it into legend. No indigenous stories, no colonial accounts, just bones in the dark waiting 20,000 years to tell us what they were. The small king of Marie-Galante, an apex predator in a kingdom of stone and shadows, a hunter so specialized, so perfectly tuned to its environment that when the environment shifted ever so slightly, it had nowhere else to go. And maybe that's the real lesson here. Evolution doesn't reward the biggest or the strongest, it rewards the most adapted. For thousands of years, Boa blanchardensis was the perfect answer to a very specific question. How do you hunt flying prey in complete darkness with limited space and no backup plan? The answer was elegance, patience, thermal vision in a world without light. But evolution is also merciless to specialists. Generalists survive change, specialists dominate until the environment shifts ever so slightly, and then they vanish. The polar bear thrives on ice, the koala thrives on eucalyptus, and a 4-foot cave boa thrived on Pleistocene bat colonies. When the bats left, so did the snake. There's something haunting about that. This animal left no descendants, no living relatives that carry its exact adaptations. The modern boas of the Caribbean are different species entirely, which means every specialized trait that made Boa blanchardensis the apex predator of those caves, the vertebrae spacing, the sensory pit arrangement, the specific striking angle optimized for mid-air interception, all of it died with the last individual. Evolution isn't an archive, it's a lottery, and extinction doesn't care how perfect you were. But here's the thing that keeps me up at night. We almost never found this snake at all. The only reason we know it existed is because Bo-Katan and Bayonne were searching caves for fossils in 2011. If they'd picked a different island, a different cave system, a different research grant, this predator would still be unknown. Which makes you wonder how many other specialists lived and died in the margins of history. How many other small kings ruled forgotten ecosystems and left nothing but anonymous bones? The fossil record is a library where 99% of the books have been burned. And Boa blanchardensis was one of the lucky ones. It, at least, got a name. If you want to explore more forgotten monsters of deep time, species that dominated their worlds and left nothing but questions, hit subscribe, because this island had other secrets, and some of them are still down there in the dark.